Good morning, and welcome back to this lecture of semiconductors of semester two. Myself, Dr. N.D. Meshram, Head Associate Professor, Department of Electronics in Mathura Das Mohta College of Science, Nagpur, Maharashtra. And uh, in the last class, we have studied about the PN junction diode and how it is being formed, right? So what we have studied yesterday, I will just repeat it for you. I have told you that when a single chip of pure intrinsic semiconductor is doped half of the portion by a trivalent impurity and another half by a pentavalent impurity, then at this part of this we'll have a p type of a semiconductor. Similarly, on the other side we'll be having n type of a semiconductor. At the center, when they are very close to each other, there are in this line there are excess of electron, and here there are the requirement of electron, right? So what they'll share those electron, and the neutral portion will be formed. That particular neutral portion will we are calling it as a potential barrier, or say the depletion layer, right? Why it is called as depletion layer? Because the further movement of electrons from this side and the movement of holes from this side are being depleted by this neutral surface, right? And therefore it is called as the depletion layer. It is also called as internal potential barrier. Now the internal potential barrier looks like a cell, right? So it is actually a potential barrier of around zero point 0.7 volt for silicon and zero point 0.3 volt for germany. Okay, so this is how the depletion layer is formed, and as soon as this junction is formed, we call this as a PN junction diode, right? So we call this as a PN junction diode. It is a P type, it is an N type, and this is a junction in between. And since we are taking two electrodes out of it, we are going to call it as a PN junction diode. Okay, so this is about the formation of a PN junction diode. Now, the working of PN junction diode. I have told you this is actually the symbol of the PN junction diode, and this part is called as anode, and this part is called as cathode. Now, remember this: when I'm showing you the arrow, the triangular which is showing you the arrow, that it implies that the flow of current. Now, whenever you are drawing any of the symbols of any of the semiconductor devices, will be having some arrow over there, which clearly indicates the direction of flow of current, right? So remember this. This arrow is going to show you the direction of flow of current. Means if we are going to connect this anode and cathode, the current is going to flow from anode to cathode, right, and not in the reverse direction. Okay, so this is the formation or construction of a PN junction diode, right? Now let us see its working. So while seeing it working, what we need to do is we need to connect it to a power supply, right? So how we are going to connect it to a power supply? We need to connect it. So for that, I am directly going to connect it to a battery. So we are having a battery like this, so we call this as a battery. Now, what is this? Why we are using this type of a symbol? This is positive and this is negative, right? I guess it is visible to you. Is it visible? Positive and negative, or I
Yes, sir.
hope it is visible to you, no? Right. So it is showing you positive and negative. The bigger line is always positive and the smaller line is negative. Now why is it so? Because the bigger line shows you the higher potential, whereas the small line shows you the lower potential. So with respect to this, it is at a higher potential, and with respect to this, it is at a lower potential. Therefore, we call this as a battery, and this is the symbol of a battery. Now we are connecting it in this way. So since we are having two terminals, positive and negative, so the diode can be connected in two types, right? So I have connected in first like this. So we can have a reverse also. So we will see both the types. So now what we have done, the first working of this, that is called as forward bias characteristics of a PN junction diode. Remember this. This is a heading: forward bias characteristics or forward bias characteristics of a PN junction diode. Now, in forward bias condition, the first point: when the positive terminal of a battery is connected to P type and negative terminal of a battery is connected to N type. Positive terminal P to P, N to N, right? So positive terminal of a battery is being connected to the P type and negative terminal of the battery is connected to N type. Then the diode is said to be in forward bias condition. Now, how it works? How it works? It says we have directly connected to it. So this is actually the internal diagram of that PN junction diode, and this is the symbol. So we'll connect this also. And if we get time to do our practicals, if we have started with offline classes, we will try to complete your practicals. So we need to will be doing this forward and reverse bias characteristics of a PN junction diode, LED, and the other diodes. Right. So for this, the PN junction diode. Uh, so this is how it is being connected. So when the P type positive terminal of a battery is connected to P type and negative terminal is connected to N type. Now what happens when it is connected as like this? Then the positive holes are going to be repelled by this positive potential, whereas the negative electrons in N type are going to be repelled by the negative potential connected to the battery. रिमेंबर दिस जब हम लोग इसको ऐसे कनेक्ट करते हैं तो क्या होता है ये पी टू पी लगाया है राइट फॉरवर्ड बायस कंडीशन की बात कर रहे हैं हम लोग जब पॉजिटिव टर्मिनल पी टाइप को लगाते हैं तो ये पॉजिटिव होल्स है ये पॉजिटिव टर्मिनल पॉजिटिव होल्स को रिपेल करेंगे ये नेगेटिव टर्मिनल की वजह से नेगेटिव इलेक्ट्रॉन्स को रिपेल करेंगे राइट so in English just try to understand that in English how we are going to say when the positive terminal is connected to the P type and the negative terminal is connected to N type, the positive holes are going to be repelled by this positive potential. Similarly, this negative electrons are going to be repelled by this negative terminal of the battery, and accordingly, what happens? The depletion layer, all his electrons goes closer, and the depletion layer goes on decreasing. The depletion layer will be smaller, will become smaller, right? So as you increase the voltage like this, if you increase the voltage, why I have drawn this arrow? It is a variable power supply, right? So when you vary this voltage from 0 volts to say certain volts, so around zero point 0.7 volt for silicon, around zero point 0.7 volt for silicon, this depletion layer gets dissolved, right? So the potential, net potential or the internal potential barrier of this simple PN junction diode is around zero point 0.7 volt for silicon and say around zero point 0.3 volt for germanium. So when we apply, if we call this as a silicon PN junction diode, then at zero point 0.7 volt, this depletion layer will be dissolved, right? And the current will start flowing through this. So the current is going to flow from say positive to say negative like this. So the arrow shows that the current is going to flow from the anode to cathode, right? So current starts flowing through this diode, and we say that the diode is in forward bias condition, right? So after that, the diode will work. So we call it as a forward bias condition of a diode. Okay, so right. So this is a forward bias condition of a diode. Now, the diode conducts in forward bias, right? We call it as the diode conducts in forward bias, right? Okay, so this was the first condition. You need to write all those things. So remember all the words that I'm telling you. Yeah, so first condition is the forward bias condition. I am repeating it for you. When the positive terminal of a battery is connected to P type and negative terminal of a battery is connected to N type, we call it as the diode is in forward bias condition. Right? The diode is in forward bias condition. Okay. And what happens when we increase the voltage from 0 to 5 volts or 0 to zero point 0.7 volt? The positive, due to this positive potential, positive terminal connected to this P type, the holes are going to be repelled, and similarly this negative electrons are going to be repelled by the negative potential of the battery, and they are going to reduce the depletion layer, or the depletion layer will go on decreasing. After zero point 0.7 volt for silicon, say, the depletion layer will be dissolved. The depletion layer will be dissolved, and the current will start flowing through the diode, and we say it as the diode is in forward bias condition. The diode is in forward bias region, or the diode conducts. Remember this, the diode conducts in forward bias condition. Okay, so I have told you. So this was the first part of today's lecture. Now the second part. So we have studied the forward bias, FORWARD, forward bias. Biasing means the connection of the battery to the device. That is called as biasing. Forward means when it conducts, that when the current flows through that, then it is called as forward bias condition. The second one is the reverse bias condition. So in reverse bias condition, what will do? Again, reverse biasing means we are just needing to connect it. So reverse bias means we'll change the polarity of the battery. So now we are going to connect the negative terminal of the battery to P type and positive terminal of the battery to N type. Again, if you do like this, if you connect a negative terminal of a battery to P type and positive terminal to N type, we call it as the diode is in reverse bias condition. Now, what happens in reverse bias condition? As you have studied in forward bias, just recall or just try to understand what is going to happen. In forward bias condition, when we have connected this, the positive terminal to P type and negative terminal to N type, they were repelled by the potential, the voltage applied over it, and due to that, the depletion layer will was gone decreasing and it dissolved. Right? This was in the forward bias. Now in reverse bias, what will happen? It will reverse of that. So during that condition, what happens? The electrons are being attracted towards the positive terminal and the positive holes are being attracted towards the negative terminal. The depletion layer will go on increasing, right? Since the depletion layer will go on increasing, no current is going to flow from the diode, right? The diode does not conduct in reverse bias condition. I guess you have understood this. The diode does not conduct in reverse bias condition. Remember this. So diode conducts only in forward bias condition and diode does not conduct in reverse bias condition. This is for sure. Now, but if you go on increasing the voltage and if it reaches say around the peak inverse voltage of a diode, which is around say 180 degree volt, 180 volts or more than that, around 180 volts, 180 volts. So we won't work for 180. We just work for 0 to 12 volts, not more than that. But if you go on increasing the voltage and if it reaches the reverse voltage reaches at 180 degree, 180 volts, then what happens? The depletion layer, where we are having some neutral particles, neutral atoms over there, which are saturated, now they break, right? And as soon as they break, what happens? The reverse current starts to flow. The reverse current is very small, the leakage current. So small leakage current flows through the diode when it is connected in reverse bias due to majority charge carriers. Now remember what is majority and minority charge carriers. I have told you. In p-type semiconductor, holes are majority charge carriers and negative ions are minority charge carriers. Similarly, in n-type region, negative electrons are majority charge carriers and positive ions are majority charge carriers, minority charge. So due to these minority charge carriers, some leakage current of the at the range of microvolt flows through the diode, right? So since it flows through the diode, the very small current, microvolt, so it is negligible, right? So that flows through the diode. That is called as a simple leakage current. But as you go on increasing the reverse voltage, say around at what 180 degree, 180 volts, then what happens? Some covalent bond may break. Some of electrons may make them free, and they might push or say target or say uh, force some more electrons to break the covalent bond. So what happens? 1 to 2, 2 to 4, 4 to 8, 8 to 8 to 16. It goes on. So as you go on increasing the voltage, the electrons over here will increase due to the breakage of covalent bonds, right? So this phenomena which is called which is breaking down by say 1, 1 to 2, 2 to 3, and 4 to 5, 4 to 8, 8 to 16, like this, then that is called as the avalanche uh, condition. Avalanche condition, and the depletion layer breaks, right? And a huge amount of current flows through the diode. That is called as the avalanche breakdown, and the reverse current flows through the diode. But that is at a very high voltage, that is around 180 or more than that, right? So that is actually called as the peak inverse voltage of a diode, right? So this is how the diode works in forward bias as well as in the reverse bias. So if you have any questions, you can ask on that. Okay. Again, I will repeat it for you. I will repeat it for you. This is a forward bias condition when the positive terminal of a battery is connected to P type and negative terminal of a battery is connected to N type. We call it as the PN junction diode is in forward condition, right? Forward bias condition. Now, what happens? When the positive terminal is connected to P type and negative terminal is connected to N type, the positive holes are being repelled by this positive potential of the battery, and negative electrons are being repelled by the negative potential of the battery, due to which the depletion layer goes on decreasing. And after say some voltage, that is around say zero point 0.7 volts, the depletion layer dissolves and the current starts from flowing through the PN junction diode, and we call it as the diode is in forward bias condition, or the diode conducts in forward bias region, right? Okay. Similarly, when we connect the potential, connect the battery in the reverse order, that is, when we connect uh, negative terminal of a battery to P type and positive terminal of a battery to N type, we call it as the diode is in reverse bias condition. Now, what happens in this reverse bias condition? Since it is connected to negative terminal, the positive holes are being attracted towards this negative potential, and the negative electrons are being attracted towards the positive potential of the battery, due to which the depletion layer will go on increasing. So it will increase. This will increase, and as soon as it expands, there will be no current flowing through that. But due to minority charge carriers, which are say negative ions in P type and positive ions in the N type region, a small leakage current flows through that at the range of say around microvolts, which is absolutely negligible. So that is unwanted, but still there is a small leakage current flowing through that. That is called as the reverse leakage current, and that has got a very good importance in when we will study transistors, right? So remember this. This is what we are having in reverse bias condition. A very small leakage current flows through that. Okay. So yeah. So very small leakage current flows through due to minority charge carrier. Now let it be. Even if you go on increasing the voltage at a very high volts, that is around say the peak inverse voltage, we call it as around say 180 degree, 180 volt or more than that, the depletion layer breaks, right? So one of the covalent bond breaks, and due to that, it will break another two covalent bonds, and two will break four, four will break eight, eight, and eight will break 16, and so on. There is so many electrons are available on in this depletion layer, and due to which it suddenly breaks, right? And that is called as the avalanche breakdown. Remember this. This is called as the avalanche breakdown, right? When there is a breakdown in reverse bias condition in a simple PN junction diode, we call it as avalanche breakdown. This is the avalanche multiplication. 1 is to 2, 2 is to 4, 4 is to 8, 8 is to 16, 16 is to 32, 32 is to 64, and it goes on. That is called as avalanche multiplication. And there is a huge amount of population developed within a second in this depletion layer, and suddenly it breaks, and that breakdown is called as the avalanche breakdown, right? In reverse bias condition. So in reverse bias at a very high voltage, the avalanche breakdown takes place. I guess you have understood this avalanche breakdown. Now we'll try to draw a graph. This graph is expected to be drawn in your practicals, right? So when you'll do practicals, I expect from your side that you are going to draw this diagram. Now let us see how to draw a graph. Even if you are knowing that you might be knowing the graph. So we call it as the XY axis. So this is the X axis and this is the Y axis. You might be knowing this. So X axis and Y axis, but it's my job to tell you why we are taking this. So whatever parameter we are going to change. So since that is in our hand, so whatever parameter we are going to change, we are going to take it on x-axis. Remember this. Whatever we change, we take it on x-axis. So we are changing here the voltage. So we'll take it on the x-axis. So positive volts and negative volts. Similarly, due to this, what is going to change? The other parameter is going to change, and that other parameter we are expected to take on the y-axis. So we are going to take current. So here it is positive current, here it is negative current. We are having the quadrants first, second, third, and fourth. So we are having four quadrants over there. So in the first condition, that is the forward bias condition, will be taken in the first quadrant since both are positive. So we'll have a positive voltage and a positive current, right? So when the graph shows like this, when we start from zero, it will be slowly and then it will increase rapidly like this, right? So this particular point is called as a knee voltage, KNEE voltage. I guess it is visible to you. I have written here knee. Knee means ghutna. KNEE. It looks like bend. It looks like knee of a person, and therefore it is called as a knee voltage. So we have a definition of it also. So this is a knee voltage. I will define it. And in the reverse bias condition, it will come in this third quadrant. So at a very reverse voltage, a small leakage current flows through that is being shown, and at a very high voltage, we'll have a steep breakdown. We will have a breakdown like this. So we call this as a small. We'll show this. This is a breakdown voltage. I have written break, BREAK, down voltage, right? So breakdown voltage, and the last one is yeah. So at this point, it will have a reverse breakdown. So somewhere it is shown like sometimes it is shown like this, or sometimes it is shown uh, like this. So this is a straight line, and it might be shown like this. So this is the point. This point is called as, I will write it as A. So A dash is the uh, breakdown voltage, right? I will define this. So knee voltage, what will be the knee voltage? Now try to remember or understand the definition, how you are going to define this. So what is a knee voltage? Knee voltage is that forward voltage at which the current starts rising. The current starts flowing through the PN junction diode. That particular voltage is called as knee voltage. Remember, this is in forward bias. So that is the knee voltage is that forward voltage at which the forward current starts flowing through the diode. What is the breakdown voltage? That is the reverse voltage at which the simple diode breaks and the current starts flowing through, maximum current starts flowing through the diode. That particular voltage is called as the breakdown voltage. There are some more definitions we'll study in the next class. I guess you have understood today's lecture. We have studied forward bias characteristics of a diode, reverse bias characteristics of a diode, and I guess you might be making some notes on that also. So try to write something on that. At least you should be able to recall those things. So that is what we do in your exams also. We try to we have a question and we try to recall what we have studied or what we have understood, and we try to write on that. Okay, and that particular phenomena we always do. So every time I expect from your side that you should try this every day. Okay, so this was the PN junction diode and the working of the PN junction diode in two conditions: forward bias and reverse bias. I guess you have understood this, and hopefully, if you are having any questions, you can ask me on that. So, are there any questions? Yes, Mrunal.
सर सर एक बार नी वोल्टेज और ब्रेकडाउन वोल्टेज की डेफिनेशन
हाँ बेटा
बताइए ना.
वो आई विल डेफिनेटली लिव नी वोल्टेज इज वोल्टेज एट दिस इज अ फॉरवर्ड वोल्टेज राइट ये वाला पॉइंट है वो So this is the forward voltage at which the diode starts conducting and the current flows through the diode. है ना, यहाँ से क्या हो रहा है, यहाँ से करंट फ्लो होना स्टार्ट हो रहा है, और ये कौन सा रीजन है, फर्स्ट क्वाड्रेंट, जहां पर हम लोग इसको बोलते हैं दिस इज द फॉरवर्ड बायस कंडीशन, एफ डॉट बी, मैं यहाँ लिख रहा हूँ फॉरवर्ड बायस. So forward bias condition is in the first quadrant. So that is the voltage at which the current starts flowing through the diode. Breakdown voltage क्या होता है? This is a reverse voltage at which the current starts flowing through the diode in reverse direction. Right? That is called as the breakdown voltage. जहां पर break होता है, that is very peak inverse voltage. तो यहाँ पर बहुत सारी definitions है, ये definitions हम लोग पढ़ने वाले हैं in the coming classes. I have just touched it. So ये बाकी का इसमें कोई प्रॉब्लम है क्या? We have many definitions on this, so I will let you know on this. Okay, so is it okay? Shall we end up the class? Okay, thank you very much for joining the class. See you in the next class soon at the same time, hopefully. Okay. So thank you very much for joining. Stay home, stay safe, take care, and please watch my videos on YouTube. Please like, subscribe my channel, and share the videos. Thank you very much. Have a nice time. Stay home, stay safe, take care. Bye. Good day. See you.